Good afternoon, everybody. We will wait for another 5 minutes for the rest to come in on the meeting, and then we will start in 6:05. Good afternoon again, and welcome to today's webinar about implementing artificial intelligence in cybersecurity. My name is Elena Dimovska, and I'm data analyst in CMOS Education. Also, I have the role of product owner of Artificial Intelligence Academy. I'll be your moderator for today's event, And also with me today is Goce Stevanoski, researcher and teaching associate, expert in cybersecurity, who will demystify the use of AI in cybersecurity. At the very beginning, let me introduce you with the organizer of this event, CEMOS Education. Actually, the main task of CEMOS Education is developing a wide range of courses designed for various end users with a different level of computer technology knowledge. Special attention is given to the cooperation with companies and institutions, organizing a customized training for them, focusing on their needs and their internal development. CEMOS Education also acts as a service for educational support for companies in the region. CEMOS Education develops a system of computer education as an informal education which elevates the rank of the computer education. Together with the learning system, which is developed continuously, CEMOS Education is coordinating and organizing a system of knowledge certification regarding the international certification system. Equipped with sophisticated information technology and highly educated and experienced training staff, CEMOS Education sets the standards in education quality for over 27 years. Actually, the birthday is tomorrow, 28 years. CEMOS Education's team is consisted of over 160 people, of which around 40 are full-time employees and 120 external certified trainers. These outstanding features gives us credibility as a cutting-edge IT training to make a distinctive mark in the field of AI with our exceptional curriculum and well-experienced instructors. So some of our products are, for example, Artificial Intelligence Academy, which is a product and academy where the level of knowledge for this course is a beginner, and the target audience is everyone who wants to learn more about AI, from students, developers, or data scientists to industry switchers, and as I said, everyone who wants to learn more about the new artificial intelligence field. The program includes Python as program language, artificial intelligence and machine learning in its foundation, to PyTorch and NLP modules, including CYB or Certified Artificial Intelligence Practitioner course as an expert level course. Then we have Certified Artificial Intelligence Practitioner for experts level, which is a short course where you can learn more on advanced level, of course, for machine learning models and artificial intelligence, and using artificial intelligence and machine learning models. Then the next product that we can offer from our portfolio and is correlated with artificial intelligence is AI Ready, which is actually ongoing course now. And of course, in that course also, you do not have any experience or any knowledge, and you're starting from the beginning and learning about Python, and then a mathematical foundation, of course, artificial intelligence and machine learning fundamentals, and then you are going a little deeper in that knowledge, learning about Python. We have some AI generative courses, of course. Those are in creative industry. So we have designing with AI as a course where you can learn more about Adobe Sensei or Adobe Firefly and Midjourney and how to use AI in the creative industry. Of course, we have some Microsoft courses, AI 900, which is Microsoft Azure AI Fundamentals, where you can learn more about artificial intelligence and using Azure as a cloud, where you can learn more about services that Azure and Microsoft offers for artificial intelligence and machine learning deployment. In the webinar series, I would like to extend a warm welcome to today's webinar on a crucial convergence of technological innovation and digital defense, implementing AI in cybersecurity. As the cyber landscape grows increasingly complex, organizations worldwide are turning to artificial intelligence to fortify their security measures. This webinar aims to provide you with a comprehensive introduction to the pivotal role that AI plays in bolstering cyber resilience. Throughout this session, we will delve into the foundational concepts of AI integration within cybersecurity frameworks. Our esteemed cybersecurity expert Goce Stevanoski will explain how AI-driven solutions are revolutionizing threat detections and risk mitigation strategies. By understanding the symbiotic relationship between AI and cybersecurity, attendees will gain invaluable insights into harnessing AI's potential to proactively identify and combat emerging threats. Our speaker brings a wealth of experience to the virtual podium, and with a focus on real-world applications and tangible outcomes, we will explore a case study that spotlights successful AI implementation in a security scenario. Furthermore, we will navigate to the policy frameworks that accompany AI deployment, underscoring the significance of responsible and transparent practices. In conclusion, today's webinar serves as a compass in guiding us through the uncharted territory where artificial intelligence meets cyber security. We invite you to engage in the Q&A Teams option, of course. Pose your inquiries to our expert and glean insights that will empower you to navigate the evolving digital threat landscape effectively. And of course, thank you for joining us today. And we trust that this session will equip you with the knowledge and tools needed to embark on this transformative journey of AI integration in cybersecurity. So now I will let you to listen Goce Stevanoski and learn more about implementing AI in cybersecurity.
Thank you very much, Helena, about the introduction part. It was nice to hear all of that. Let me just share my presentation first. Is it okay? Can see the presentation, everyone?
Yes, Goce, it is okay.
Thank you very much. So welcome from my side to all of you who find time to dedicate for this today's webinar. I hope that is going to be worth it for all of you. When we speak about artificial intelligence and its implementation in cybersecurity, somehow we can notice it's complementary between themselves. AI finds a lot of implementation in different fields, like in finance, in education, in healthcare, but in cybersecurity somehow goes one with another together, because cybersecurity is part of this bigger cyberspace in which we have interconnected systems that are dealing with data, dealing with logs, and the data and logs is something which is give the foundation for successful implementation of AI. So AI is let's say meant to be with cybersecurity. About today's webinar, I'm going to give a short overview of all the parts that I'm going to cover. So we're going to start with some entry definitions. We're not going to talk too much about, too in depth about the definition, because AI and cybersecurity are very big field. But I want to talk about some definitions so that later you can have good understanding what we are talking about. Then we're going to move to the cybersecurity landscape for AI, which are the potential challenges for AI in cybersecurity and where AI can help. We're going to conclude with advantages of using AI in cybersecurity. Also, I'm going to give some overview of the institutions that are what is their approach to artificial intelligence in cybersecurity, the adaptation of artificial intelligence in the cybersecurity companies, mainly here in the cybersecurity service providers. Then short overview of the cybersecurity jobs and artificial intelligence, how the AI is influencing the jobs in cybersecurity. And we're gonna end with a demo, which is anomaly detection with autoencoder deep neural network. So this is an overview of one, let's say, comprehensive overview of what's going on in cybersecurity, leveraging the artificial intelligence. So what is artificial intelligence and where is machine learning in all of that? The definition about the artificial intelligence is, let's say, still not concrete, because it's in every new technology like cyberspace or other terms, they don't have strict definitions. People tend to give definitions in the sense of how they are used. I like the definition about artificial intelligence when we are talking about the main features of AI. So it's a perception of the environment, including consideration of the complexity of the real world, which is giving a good overview what AI is doing. Information processing, mainly extracting information from a given data, and then making decisions, taking actions, performing different tasks, or even achievement of already given specific goals. So this is one interesting explanation and definition of artificial intelligence. And when we talk about the machine learning machine learning as a part of this field of artificial intelligence, we must say that machine learning is a subset of artificial intelligence, but is a subset that it fuels artificial intelligence with necessary pattern recognition, with necessary advanced statistics inside, so that gives to AI this opportunity to AI do all the main features that I mentioned previously. So in machine learning world, on the other hand, we have two distinct categories. The one is traditional machine learning, something that was mainly done until the beginning of 2010. It's still in the form of research. All the machine learning methods in the traditional machine learning, also called nowadays shallow learning, are very applicative to these days. So, for example, support vector machine it's a great algorithm that can be used in classifying things. But somehow, after the stepping on stand by Alex Annett, many things have changed, and people start to work more in artificial neural networks. So the deep learning came to steam. To support my theory that machine learning in cybersecurity was even before 2010, I'm on the right side. I have here an article published by Microsoft in 2007, in which they're proposing an algorithm for automated malware classification. Whoever worked in 2010, 2012 with malwares and the tools about that was Microsoft using at that point of time will remember that after this article they have this let's say advertising of their products, like we are working on behavioral analysis, we are working on heuristic analysis. So they wanted to emphasize they're implementing machine learning in their products. So machine learning, it's not started even in 2007. It started even before that, but it didn't get that attention like in now the last years. So I can say that the approach of using machine learning in cybersecurity is here, but the question is the artificial intelligence here? Because in the recent years, many cybersecurity providers, companies which are working in cybersecurity, they have implemented tools supported by machine learning, but is the artificial intelligence here? That's something that in the moment we are trying to figure out. So the current state of artificial intelligence in cybersecurity, it's something that it has a potential. In the current stance, we want to see the potential challenges of enforcing AI in cybersecurity. So some of the potential challenges are in every field of cybersecurity. I'm going to mention two very important things. It's a threat detection and monitoring and control of the network. So these are the areas in which AI of cybersecurity is giving a lot credibility and can help a lot in all the cybersecurity professionals. In threat detection, we have network intrusion detection, malware detection, phishing detection. All these detection applications are part of the process of securing the network. And we have the other part, monitoring control of the network, where artificial intelligence can help in various other segments like alert management, raw data analysis, risk exposure assessment, cyber threat intelligence. As you can see here, we have covered a lot of the cybersecurity landscape where the AI can have a potential to solve some challenges. So the security life cycle spans on these three processes which are mentioned here: prevention, detection, and reaction. Most of the systems which are nowadays used, they are focused on detection, because prevention, many things we cannot prevent. For example, we cannot prevent creation of a phishing website, but we can detect if some phishing website is already created. Also, we cannot, if we came to a stage in a reaction stage, then it means that we already have some kind of intrusion into our network. So detection is very important in the whole life cycles of the security in cybersecurity. And in that sense, we have detection, which we have two categories in which the detection techniques are used. The first one is misuse-based, which refers to signature or rule-based, in which we know the tools, we know the threats, and then we are configuring in our systems to notice the threats that are coming into our network. And the second is anomaly-based, in which, on the other hand, requires having a sense of normality of the network. And if the system recognizes something which is not normal, for example, if we have huge data leakage in 3 in the morning, and when nobody is working, then the system should alert us. I am just pointing out some things that later on will be interesting for implementation of AI inside those systems. So the first system which is using artificial intelligence or using machine learning at the moment, and artificial intelligence, of course, already is implemented in some of the new portfolios, is the network intrusion detection system. Network intrusion detection system is the system which lies in the network and read only the data which is traveling into our trusted network. So network intrusion detection, NIDS, is the system that can successfully leverage these capabilities of AI. So it can capture different types of data, full package captures, network flows, SNMP, data, DNS records, HTTP, any type of data. So if artificial intelligence systems or tools are implemented into network intrusion detection systems, then we can have successful detection. Some of those applications of implementing machine learning or artificial intelligence include clustering various machine learning techniques, so that they can make separation in the traffic that they are getting in. So the traffic gets in one machine learning method, then it's filtered, then goes to another one, it's filtered, and on the end of it, it can give us result. Does the traffic has some kind of malware inside, malicious traffic or not? Also, the support of manual generation of rules, something that I mentioned in the previous slide, that about the misuse. The artificial tools now can help us to build rules more effectively. They can scan the network, they can see the potential of problems, and they can update the rules automatically. So if we had previously building of rules, building of signatures by hand by people who are working on the systems, now we can use artificial intelligence tools that they can build our rules. Detecting the attacker lateral movement is something that I find really interesting and very good implementation of machine learning and artificial intelligence tools. Because when we talk about lateral movement, it's something which in the last couple of years predominantly threatens the network is the ransomware. Ransomware are malicious software which, when enters into the network, for example, in this network here, then scans the administrative credentials, and when he has administrative access to all the other parts of the network, then goes to the other part. So laterally goes to the network. That means that if we see in our anomaly-based system, as I said, if we see not a normal behavior of the systems that they go that they are spreading around the network laterally, then the system, which is, if it's AI based, can react and can stop that, or at least give a alert that something is going on to the network administrators. The next part in which AI finds its potential is the malware detection. The malware detection, it's a huge topic, always has been a huge topic since forever. So the artificial intelligence inside the malware detection can be very productive. In the malware side, we have static and dynamic malware detection. The static, we are detecting the signature. It's a signature base, so we are detecting all these malwares, all these files, processes in the network that are already known. And in the dynamic malware detection, then we have detection of how the malware is behaving, which processes the software is starting. When we know that when we know the pattern of starting different processes, then we can say it's a malware because started this and this and this process. So the applications of AI include use of deep learning and extracting this relevant dynamic feature. So when we have implemented AI tools in this kind of scenarios, when we have dynamic malware detection, then we can see what's going on in the network, and then achieve and classify Android malware, for example, in this research. So I have based this percentage here from different research articles that I found. So you can see that implementation of deep learning techniques, machine learning techniques, and AI techniques increases the detection of malicious software in different percentage, but most of them are like more than 80%, most of them more than 90%, because we have approach with using combination of static and dynamic analysis of various machine learning techniques. So all of that give us opportunity to make huge detection of malware in the computer systems. I must emphasize that we cannot expect that the AI tools or whichever tools we have is going to be 100% precision. There is no 100% security when we talk about cybersecurity, and that we must know. But if we have like 97% precision in Windows ransomware detection, that's a very good system. The next threat is the phishing detection. In the phishing detection also as malware is been part of the threats in cybersecurity for many years. We know that most of the traffic that goes on internet is spam traffic, and the spam traffic is mostly filled with advertising and phishing emails. Phishing emails that lead to phishing websites Also, there are phishing links that lead to phishing website, and detection of those phishing websites is the goal, is the challenge that AI in cybersecurity can help. Also, not only detecting where the phishing website I created, but the AI can help into detection of phishing emails. The phishing emails, which are now, so we may say that because we have so many emails, the current techniques which are employed, for example, in Google, in Microsoft, are so sophisticated they can recognize with a very big percentage very big percentage. They can recognize that there's a potential phishing email in your inbox, and that's why the email goes to spam. So AI is here, but I think that with the advances of the new large language models like ChatGPT, Llama, and others, the phishing email detection, it will be even more accurate. There are some discussions about that ChatGPT actually increased the volume of spam emails and phishing emails because it gives a very good, it is a very good tool so that you can write an excellent phishing email. But if we go through the phishing emails that were previously, we can see that even if previously we had very good written emails, which are phishing emails. So here AI and the new tools that are coming out, especially in the natural language processing, can really help into countering these phishing attacks. In the part of monitoring and control of the network, AI can have its own. It can a huge role into these fields like alert management, raw data analysis. In alert management, if we go to anomaly-based systems, they are good when we have this normality, and then we have problem with the normality and the alarm is raised. But those systems usually raise a lot of alarms. So alarm filtering, alert prioritization, alert fusing is something that AI can do it with the various data previously collected. They can be categorized, filtered, give them prioritization, and then then from that we can extract information that will help into finding the most relevant alert that we have now. And the SOC team, for example, in Security Operations Center, can address the right alert and the right problem, not go around in different alerts. Raw data analysis, on the other hand, AI with its capabilities, especially with the deep neural networks and the capabilities of extracting different features from the raw data, it can help into faster analyze of the logs, faster analyze of the traffic, and then giving operational capabilities to the, maybe not automatically making decisions, but it can give decisions, suggestions to operational personnel that it can work with the data. For example, if the AI detects that there is a problem, that there is in the log files in the server, it's in the file server, there is a huge leakage of data, and on the firewall it's open some port which shouldn't be open, then you can correlate the data and give a suggestion to the operational center that there is a problem with this and try to fix that one. Labeling optimization is something that can help with in the raw data analysis, because not always we have good data that we can work on our system. So AI, it needs data. And when we don't have much data, then we can take some data that is good for us, and then with the AI, we can make more of that in the similar sense, so that we can train new AI models. In the risk exposure assessment, also huge field in cybersecurity. The penetration testing is something that is that in the recent years become a must for big companies. AI is is also these AI tools in penetration testing. In penetration testing is very interesting approach because sometimes people are concerned about what AI can do with the power that is given to go to the network, to automatically scan the network, find vulnerabilities, implement some kind of exploits. But on the other hand, it's very helpful because penetration testers, they can have more time they can easily find more problems. And if we go to the research papers, we're gonna see that this penetration testing with help of AI gives a significantly better results than just regular penetration testing because it's automated, because AI is working with its possibility to create and to take different tools and implement them and try them on the network very fast than a person that can do it by themselves. Estimation for compromise indicator, it's the same field in which AI can help in giving estimations. Cyber threat intelligence, it's also one field in which AI is helping a lot. With the cyber threat intelligence, AI can help in finding the internal sources. So, for example, if we have already problems in our network, the AI can help into gather the data, then process that data in some form that it can be usable, and then implement it in the next cycle of threat analyze and or give that to the IDS systems or to the firewall so that the firewall knows about it. From external sources, of course, a lot of things can be useful, especially the databases with critical vulnerabilities. So the artificial intelligence application, when we talk about the implementation in one environment, doesn't need that to be a business. It can be some institution. It can have two types of implementation. The one is in-house, and the other one is to outsource the problem. Why I'm pointing out this here? Because I want to emphasize that having artificial intelligence tools in your environment, it depends, or leveraging artificial intelligence in cybersecurity for your company very much depends of what kind of company we are talking about. If the company is a huge one, like Tesla, Facebook, or I don't know, some big company that can have its own personnel, that can pay people who are going to work on its own AI tools, then it's better to have in-house solution, because with the in-house solution, you have your own equipment, you have your own people, and you are securing your corporate information and your privacy of your customers. That's, for example, now it's doing Tesla, because it's not good if the data of customers, the private data of the customers, they go out to some other server so that everyone can see who is driving the car. I don't know, Tesla to some other place. Also, outsourcing the problem, it's also a good solution if there is a team that can work with the application of artificial intelligence in cybersecurity for your company. But in the outsourcing of the problem, this problem about the privacy should be taken care. The consideration is that you will pay a smaller amount of money than in-house solution. So what are the functional improvements of using AI in cybersecurity? We talked about what are the challenges, how AI is addressing them. But when we get all together, we can say that one of the functional improvements is the enhanced threat detection. So we had threat detection previously. We had threat detection with hard coding, with machine learning, classifications, as Microsoft was doing. But nowadays, AI systems, they can scan enormous volumes of data very fast, and they can do this effectively. They can suggest a cyber threat. And that's why we can say that AI is enhancing the threat detection. We had previously threat detection, but with AI, we are making that even better. Shorter reaction time, of course, all these things that we talked about, the alert management, the monitoring and control, the detection, when everything is put in together, we can say that we are shortened the time from seeing the alert and working on the problem. Doesn't have to be working on the problem, doesn't have to include automatic tools. Then it's if we have fast and quality alert, we can employ a person who is going to finish the job and maintain the threat, or work to maintain the threat. Improved precision, the AI algorithms are very good for finding the weak signals. So if nowadays we have cybersecurity teams in SOC which are going through the network and trying to find out what's going on in the network, AI can find much faster and much easily the weak signals that are showing that there's a problem in the network. So with this improved precision, AI is making the cybersecurity much better. Workload reduction doesn't have to explain. The term explains everything. It can decrease the workload of cybersecurity professionals, and nowadays when there is a lackage of cybersecurity professionals, this is actually a really good thing. Cost effectiveness, many things that I said previously are helping into the lessen the cost for the companies that are implementing these solutions. Enhanced endpoint security is something which is, in my opinion, very, very important because nowadays everything starts with endpoint units. Endpoint units is the computer, the mobile phone, the tablet that the user is using. So, but if the user doesn't understand what he's doing on his computer, doesn't matter how much and how advanced systems we can have, we will always have problems. But with AI, we can enhance this endpoint security. We can make the computers, IoT devices more aware of where they are, in which category they are, what kind of threats they can have, or how can they limit the user's behavior on their computer, on their device. Now we can give this answer to the question: do we have AI? Yes, we have AI at the moment. The cybersecurity providers, they are using machine learning tools, and they're implementing AI on those tools so they can have this correlation of data and fast responsiveness. But it's beginning of it, and that's something that will stay for long, of course. I'm going to go back to this. We're going to talk about the cybersecurity providers after the regulatory institutions and their approach to artificial intelligence and cybersecurity. I put that here because somehow when artificial intelligence, especially after the ChatGPT in November, when was present, came into the scene, then many people start to discuss how we should regulate artificial intelligence. But many institutions internationally, they work on securing the system from AI or securing the AI of the system, not how AI is used for cybersecurity. One thing that I found interesting is the EU-ENISA approach to AI in cybersecurity. EU, it has its own series of approaches to different fields, like in healthcare, education. So whoever is interested in AI, it can go to EU-ENISA. ENISA is European Union Agency for Cybersecurity, and they have their views on how AI should be implemented, how AI at what stage is now, how it should be regulated, the different standardization that should be fulfilled, and so on. So this is the document about artificial intelligence and cybersecurity research. This is published in June 2023, so it's 2 months ago. It's a very new document. It's very, very interesting and comprehensive. So in that document, I took this table, which gives this this overview of where in cybersecurity the different machine learning techniques are used. So if you can, if you are familiar with machine learning, and you will see that here on the beginning we have these shallow learning techniques. So then we go to the deep learning techniques from artificial neural network, convolutional neural network, autoencoders that we are going to talk on the end of it. So this is the shallow learning part. This is the deep learning part, and all of them are useful. All of them are useful in security function for AI, which is intrusion detection. You can see almost all of them can be used in security, in intrusion detection, malware detection, vulnerability assessment, spam filtering, naive Bayes, anomaly detection encoders, malware classification, phishing detection, traffic analysis, and so on. So this document, it's supporting the thing that we speak in the beginning, that shallow learning on machine learning, it's not forgotten. It's or traditional learning, it's not forgotten. It's still used, but the deep learning is something that is taking the scene. Also, the EU and NISA gives an approach how we should develop in the future, and what are the areas that should be developed in artificial intelligence in cybersecurity. So the first is the test beds that needs to be studied and optimized. So of machine learning tools. Then is that we have to have incentivize the development of penetration testing tools based on AI. So you can see they are taking this all these fields in cybersecurity, and they give their own view what should be done in the future. Development and standardization of frameworks addressing the preservation of privacy and confidentiality, development of training in AI for practitioners for using real-world scenarios. So the idea is to have trainings for personnel who is going to use AI tools, establishing of observatory for AI and cybersecurity threats. So these are some areas which in June 2023, ENISA is giving suggestion that should be developed more. As I said, only ENISA is working in AI cybersecurity. All the others institutions, they are working more on securing AI, how to secure AI or how to regulate AI, because there's a huge discussion how dangerous is AI. On the side of cybersecurity service providers, I must say there are many ways how can we categorize these cybersecurity companies, and I categorize them by the market value in 8th of May 2023. So by the market value, there's the biggest is Palo Alto, then is Fortinet, CrowdStrike, Cloudflare, Checkpoint. So these 5 of companies are companies who have the largest market capitalization. But if we go through them to this cybersecurity service providers portfolio, we'll see that there are other companies which are also well established, but I wanted to point out some of them just to show where they are going with the implementation of artificial intelligence nowadays. Have to check the time. So these are the areas in which artificial intelligence is used in their product portfolios. It's not everything in there, but AI is used in CM, in SOAR, in endpoint detection and response. So these products of the portfolio of the companies is something in which they are used. The AI is used. I want to point out that all of them, if we go to when they have published their work in AI for their portfolio, we will see that they have published in the last couple of months that they are they are starting to use generative AI across security services. That's something which is new. That's something which all the companies are trying to implement in their portfolio. After the ChatGPT and all the different large language models that they're coming out, the cybersecurity companies, they start to somehow build their own large language models and put that in their cybersecurity portfolio so they can get the sense of everything that is going on in the network. So Palo Alto is building their own generative AI. Fortinet also is working on building their own generative AI that is going to automate security. CrowdStrike is working on introducing Charlotte AI. Also, Cloudflare is working in introducing their own generative AI for their tools in their portfolio, and Checkpoints also is working on. So we can see that all the big companies they are implementing the newest AI tools, and that's why I said it's here. AI, it's in the beginning of it, and it will stay for long in the next future. What this AI means for jobs in cybersecurity. When we talk about the artificial intelligence and the jobs, this quote which I wrote, AI won't take your job, is somebody using AI that will take your job, by Richard Baldwin in Economic Forum this year, said by Richard Baldwin. It's a professor of economics in Swiss University. But it's not originally his idea. It's something that was a couple of months ago that was going on through the network that AI will not take our jobs. Somebody who is using AI tools will take our jobs. So that means that we all have to start thinking how we can use AI and improve our job efficiency. When we see the position in cybersecurity, I've made here some general categorization of all different positions. For example, the executive position, cybersecurity operational center, risk compliance, and so AI, it will influence the most on the level of on the technical level, on the practitioner level. Yes, it will influence the executive position like CISO or incident response director, because it will give them data, they will work more efficient, but it will influence more this security analysis 1 to 4. For example, if security analyst on the level 1 is working with a phishing detection and trying to get all this, trying to somehow categorize the phishing emails and or checking the phishing websites, by using AI tools, he will probably not need it there. But that's not that his job is going to be erased. It means that he has to learn more and come to other level, like level 2, level 3, or level 4. But also the biggest influence, it will be in the penetration testing. As I said, the AI tools that are used for penetration, they have a huge impact on it. It has a huge impact on product and application development. So we know that ChatGPT writes a very good code, and it takes it really helps in producing the code for the application developers, software developers. So, but it cannot still overrate the people's imaginability in developing secure architecture, in working on risk and compliance, how on managerial level. And that's something that we can see here on this side, that from 2016, when the requirement was huge for proficiency in STEAM, it's down to 28 proficiency in STEAM. And nowadays, it's most critical skills required for the workforce are time management skills and ability to prioritize. This is research done by IBM, and it compares results from 2016, 18, and 2023. And here we can see how an industry the workforce is now. We are searching for workforce that will be more focused on that will be better in time management and ability to prioritize than into these STEAM technologies. That's because the STEAM technologies become, let's say, easier with enforcing the AI, because AI is taking some of the heavy load that the people were doing in that area. And now I will show the demo. I don't know how much time we have. I think that we're gonna finish in 10 minutes. If you have any question, please write the questions into question and question reform, questions and answers part of the Teams. So anomaly detection with autoencoder is something that I'm going to show you. It's a deep neural network. This is the overview of how the autoencoder works. If you remember, I point out the anomaly detection that is done by encoders, neural network encoders in the table of EU ENISA. This is one encoder which if anyone was working with deep learning can see that it's a feed-forward network. It works with input layer and output layer. So on the input layer we have the data that goes into the neurons. Then it's doing its mathematical calculations, and then we have on the output other data that goes out. What's specific in this autoencoder? Specific is that the data that we are entering inside should enter outside as close as possible to the or the same value to the one that we are having here. So, for example, if we input an image here, we should have the same image on the output. That's the idea of autoencoder, that we are inputting data on the input layer, and then we would like to have the same data on the output. What's that? Why is that important? First of all, autoencoders are used for data compression. So if we input, I don't know, 1 million data points here on the end, in the beginning, then in the middle where the data is compressed into a couple of neurons, then we have compressed data. So we have compressed information which is from this side, and we can take only that part of the network, and then we can use for later on, but for later purposes. Here in this example, I'm going to use autoencoder to input the data from one side and reconstruct the same data on the output. Because the data can never be the same reconstructed as the data that was inside, that's why we have XI head. So we input XI data on the input layer, and we get XI head data on the output layer. I'm not going to go too much into the mathematics of it, but I just want to know that whatever we put inside, we are trying to get on the outside. And why is that? Because we want to build a model in which the model will predict which of the data which is going through the model is malicious or benign. For example, the data set that we are going to use, we are going to split the data set into the malicious data set and into benign data set. Malicious data set is the benign data set is the normal data set. Malicious data set is the DDoS data set, DDoS traffic, and benign data is the is a good traffic, normal traffic. And then we split the benign data into two separate data sets, with which one the first is training data, and we train the model, this one here. So we are putting training data into the input layer. We are trying to get the same data on the output layer here. And then we predict the outcome by using the testing data and the machine learning model that we have here, deep learning model that we have here, and we are predicting the same data we are doing the same prediction with malicious data, and then we are doing model evaluation. The idea is that the model should give us differences between the panning data, the normal data, and the malicious data. The model should filtrate our data into two separate values, and we will see that in the example. I have to switch my. So the example that I'm going to do is done into Google Collaboratory, on the Google Collaboratory platform, and on the Google Collaboratory platform I have built this this model here, and I will explain that. So in the beginning of the training of the model, I'm going to import all the libraries that I need. I already said that I'm not going to go into details because of the time, but I'm importing a TensorFlow, for example, sklearn, pandas, matplotlib, numpy, and of course Google Colab Drive, so that I can import the dataset that I want to use. Dataset that I want to use here is Friday working hours afternoon DDoS attack. It's a dataset that is part of Canadian. That is part of Canadian Institute for Cybersecurity. So the Canadian Institute of Cybersecurity is building their own datasets for different purposes, and one of their intrusion detection evaluation dataset is CITS IDS 2017. This dataset includes various traffic collected in 1 week, and Monday, Tuesday. So on Monday it's normal completely. There is no any activity. There is no malicious traffic. On Tuesday we have brute force attack, FTP, which are using FTP, pet ether, and so on. The traffic that I am using is from Friday, and it's in the afternoon, so it's Friday morning, Friday afternoon. It's DDoS with the Lloyd 2. So it's an attack that was ongoing from 1556 to 1616, and there are some statistics about it. So the dataset, I will show you the dataset in a moment. This is the dataset. You can see that we have here on the slide, here in this window, we have 5 rows because we are showing on the head of the data, and 79 columns. All these 79 columns represent some kind of feature of the traffic, the dataset. So each row here represents observation point, which was taken from in which 79 features were taken. On the end, we have labels for every stream that the traffic is banning or is the DDoS traffic. So it is malicious. If we see the shape of the data, we can see that we have 225,745 rows of data, which collects malicious and banning traffic, and also 79 columns. This one here. Before we continue with the data, we can make a data info in which we can see all the different columns, what kind of information that we have for each observation part, destination port, so flow, duration, and so on. So whoever is in computer science will understand what's going on here. On the end, the idea is here that we can see what type of data is in that column. And you can see that we have integer float almost in every column, but on the end we have an object which is string, and that's the label DDoS or banning traffic. When we do data describe, we get some statistic about the data. Once again, the count of the observation points, the mean value, minimum, maximum, and so on. We can do some formatting. This is very good. Google Collaboratory is very good for formatting the text with pandas. So I made some changes here just to show that I can take all these zeros on the end and then make the data better. So we can see that we have removed the decimal places because we don't need that. Also, I can work on the column names because later on it will be problem for training, and by doing stripping, I strip all the spaces and replace the spaces with underscores. When I see the head data once again, I can see that I have changed everything into the column. It's a data preparation for doing the training, because I said in the chart that I show you, first of all, I'm going to take the data, then I'm going to split to malicious and to banning, and then the banning was split into test and training data, and then I'm going to make predictions with the model. With this, I'm working on some of the columns that they have values like infinity or not a number of values which we cannot train the model with because we need only numbers. We cannot train the model with strings. And I'm dropping all those columns. Those columns are like 34 columns. You can see from previously. I had 745 here, and here I have 11, which means that with this I drop like 34 observations. That is not going to influence my data, my end result, because it's a small number of observations. So if I check in the data label, I can see that I have this banning label and DDoS label. This is that's something on the end where I show you, and because of that, I can split the data to malicious, as I said, and banning. So I'm making a data set which is data mal, data malicious, and I'm making data banning. Data banning and I'm removing the label column on the end. And when I see the shape, I can see that I have only the banning data 97,686 columns. And on the malicious side, I'm doing the same thing. I have these 128,025. So when I collect this number and this number, I will have the observation points that I have in my what I have in my full data set. So by this, I separate the data to malicious and to banning. I can see that my data is in data frame, it's pandas, but here I'm making a normalization of the data, which means that if we see the numbers here, we can into data set, we can see that we have different numbers, huge numbers, like they range from 0 to million in some columns. But when I do normalization, I'm putting all those numbers in a framework of -1 to 1, so that I can have better data representation of the data set, and later I can train my model with that data representation. It increases the efficiency. So that's why I said I'm not going to go into the mathematics behind, because I just want to show you the end result, because it will take too much time. So here I'm doing normalization to see the data which is normalized, and then I can show the data. Then no, I will show you later. So data function normalized, which is NumPy, data NumPy array, and then I'm transferring the data from NumPy array to data frames. Here we can see that now we can see that the data is completely changed. You can notice because of the normalization part, we have not so much big data, the data points. So we are using this type of data for later on training. So we are not using the exact one that were here into the original data set, because this gives us very much better efficiency, and will optimize our model and will give us a better results. So the data type is pandas data frame. Here we are defining which data is going to be used for data training. So data for training is data banning normal, and we are assigned that to this variable. Then we are splitting the data training into our train and test data. As I said previously, we need that because we want to train the data set with a normal data. The idea is as if you remember from the slides, we have this anomaly detection part where we are trying to build the normality into our model, and then when the model finds something which is not normal, it's going to show us that this traffic is not normal. So we split the data. We have X train, X shape. So the data that was banning, it's around 90,000 split to these two parts. 20% is given to be as a test data, and then we are defining the input shape and activation function. So in deep neural networks, each neuron it functions on that. It has an activation function that activates the neuron when the condition is met. I'm not going into that, but here in the next cell, we can see the model that was written. So we can see how the neurons are going from 128 to 2 and then back to 128. So the data, you can see how easy it is to build these models into a Colab or some other tool. These models, we are representing autoencoder now. We are putting how many neurons is going to have in each layer. So the layer starts with 128 and then ends with 128. The data goes through all of them and should be reconstructed on the end. We give some other parameters later on, some optimizers, and the loss, how the loss is going to be calculated. This is important for us because this autoencoder is based on the loss. So if the autoencoder is making the adjustments for the normal data, and then when the malicious data will come into the feed-forward network, the loss is going to be different, and then we know that we have different data. This is the cell that we are doing that when we are training the model. So we have built the model here. We give the parameters that we need, and now we are giving a command so that we can train the model. We are training the model with 5 epoch, which means that the model is fizzed 5 times with every data set. And there will be a presentation how the loss is going lower. So this is the epoch, the first epoch that is going on. The idea is that in every iteration or in every epoch, the data goes through the model, and the loss is goes down. So because the model learns that in the output layer, the input data is not the same. So it gives with the back propagation gives information back to the on the beginning, and then is making approximation of the data on the output layer. and we can see that the loss goes down with every iteration of the data. So we are feeding the malicious data with the normal, and then we are doing the prediction with the autoencoder and the malicious. So with the prediction one, we are predicting what kind of data is going through the model, and with the prediction two, we are feeding the model with the X-test data, unseen data by now. And when we put the two predictions side by side, we will notice here that the model is making a difference between the data which is here down, this is the normal one, test data and unseen traffic, and the malware data, which is DDoS unseen traffic also. I'm referring to unseen traffic because the model haven't been seen this data before. The model only have seen the training data, which is completely different thing. But the model adjusts its weights, its parameter inside that now can recognize very good that this orange part is malicious traffic. So the traffic that is having this kind of loss is malicious, and the traffic that is having this loss is benign traffic. Here we can see that there is a overlap, but that's because we trained the model with only 5 epochs. If we do the training with more epochs, we can see the difference is becoming better. So this is the difference with 5 epochs. This is the difference with 200 epochs, which means that when we train the model, if we train the model longer, we can have better results. The model adjusts its weights better. It has a better loss function. This one here, for example, it goes very down until the loss is 0.032, which means that almost the data which is going into input level is almost the same that with the data that is goes on the output layer. And what is more important is the data set that is used. I've made another example here with a short data set of the data set that we have. I removed some of the columns. I left some of the columns. And if we go to, because I don't want to now waste more of your time, we can see on the end that because we don't have enough data, we cannot even make any prediction. We cannot separate the malicious and the benign data. This is a very good example that whoever wants to work with artificial intelligence, with machine learning, must have a good and quality data. If anyone wants to employ in its own company, it must find a way how to gather the data, how to record the data from sensors, from cameras, if we talk about some video streaming, from sensors if we talk about some machinery that is working with specific information. So I want you to have as a takeaway here that the model should be trained enough longer so that it can start recognizing the things. With a better training, we can have better results, and we have to have a good quality data so that we can have a good quality results also. I will continue with the slides once again, and I will finish. Okay, so as a takeaway of this presentation, I supported protocols here to stay. That's something that I want to point out, that AI products are becoming part of cybersecurity. AI will influence all parts of cybersecurity, will improve the precision, shorten reaction times. The regulatory framework aren't ready yet, but the work is ongoing. It's something that I point out. The overall field needs standardization. It's something that everybody is talking about nowadays. The cybersecurity providers, they are using generative AI in their portfolio. They are gripping to get there. Microsoft with their security copilot is something which is very interesting that is going on in the last couple of months. The cybersecurity jobs are affected in every functional category, but the technical will be affected the most. And the relevant data set are cornerstone for every successful AI model implementation. With that, I will conclude my presentation. I hope it wasn't too long, too bored. It takes maybe 15, I don't know, 1 hour. I'm sorry for that, but I want to show everything.
Yes, Goce,
Elena, please.
Yes, it was inspirational and knowledgeable, and it was great. And the demo and the whole PowerPoint presentation. And of course, we have one question here. It's not quite clear, but it's the same as the EDR. It means it's the same. I suppose that it means it is the same. The training and machine learning model, is it the same as and point data diagnose and response detection and response? I suppose that it is about that. Can you answer?
Well, it's not clear enough in which part of the presentation I was referring. Maybe in the part where we were discussing about endpoint
yes,
security.
I suppose. Yes.
I just want to say that in endpoint security, using of artificial intelligence and machine learning tools, it had a big problem in the last. It's always a big problem, the processing power, because to have a successful detection of malicious software in the host computers, it takes a lot of processing power. So there's a problem. Are you going to use your computer for Adobe and working on your, I don't know, making images or working on your documents, or are you going to use your computer and fully all the time scanning of the computer? But new tools, they use this cloud approach, so they send data to the cloud and are making these estimation. But it is a problem. I don't know the exact question. Should have been a little bit more explained.
Yes.
Once again, thank you for the question.
Yes, thank you, Hamza. Of course, if you need more clarification, please write down in the Q&A session in Teams. And now, while we are waiting for some questions, I want to announce that every attendee can scan this code and apply for a gift card for all AI courses in CMOS education. So I will let you some time, some minute to scan the code, the barcode, and please apply for a gift card. And we are open for any suggestions. Maybe you need more clarification about AI courses, or especially maybe in some fields, implementation AI in some industry, or as Goce mentioned, in cybersecurity. So you should feel free to ask our experts about everything that you want to know about AI. Just to check out whether there is any other question, maybe. I think that we are over our time, Goce. So yes, we should finish this webinar for today. And thank you for the great and inspirational presentation and demo. And thank you all of you for joining us today. And
thank you
of
from
course,
my side for the opportunity also.
Thank you, Goce, and have a nice evening, everybody. So see you next time.
Okay, see you. Bye-bye.
Bye-bye.